Welcome back programmers. In the today's section we are gonna talk about how to minimize loss with optimization. In the previous video we talked about how to determine the loss. So after you formed an expression for the loss, the next step is to minimize the loss by updating the model's variable. This process is called optimization. In Tensorflow has a lots of different optimization algorithms like GradientDescentOptimizer, AdamOptimizer, AdagradOptimizer, AdamOptimizer classes. You can choose whatever you want to choose. Choosing the right algorithm is critically important when coding machine learning application. You can't access the optimizer directly in your code. You need to instant one of the subclasses instead, but the optimizer class is circular because it defines the all important minimize method. Now what is minimize method? Now let's jump into the code section. So in the recipe 10 we saw how to determine the loss. So I'm gonna use these x and y and this w and b. I'm gonna change the w into random value. Let's try. So you can see in here I just use the x equal to placeholder, y equals to placeholder, and I'm gonna change the w into the np.random.rand. So w is random value. I don't know what is the w and I don't know what is the b because we're gonna change the w and b later. And you can see the model equal to w into x plus b, and this is our loss function. Loss equal to tf.reduce mean tf.power of model minus y and 2, the power of 2. Okay, so in here I'm gonna just remove all of this, and in here we are gonna create the first. We are gonna use the optimizer, and the best optimizer for beginner is the GradientDescentOptimizer. So I'm gonna create the variable name optimizer equal to tf.train dot GradientDescentOptimizer. Now you can see in the Tensorflow official site we got a lots of optimizer classes available like ADelta, AdGrad, Adam, AdMax, FTRL, and Dam optimizer, SGD, and so on. So you can use any optimizer as per your requirement, but this is the important one. And now let's use the minimize function. Now why we need the minimize function? Because we need to minimize the loss and we need our data to fit in our linear regression line. So let's try minimize. I'm gonna name it min equal to, oops, there is a keyword. So minimize equal to optimizer dot minimize, and then just pass the loss in here. And yes, I forgot one thing, you have to enter the learning rate in the optimizer. So let's define the learning rate equal to 0.01. So and they pass the learning rate in here. Now you can see learning rate is used to train our data. Okay, so you can change the learning rate and see the output and do experiment. Okay, now this is the warning, so let's remove the warning, and now let's use this optimizer. The only required argument, the first is minimize, can access every trainable variable in the graph. We just pass the loss in here. An application can select specify variable for the optimization by setting the var list argument. Minimize return operation that can be executed by session run method. Each execution perform two-step computer value that update the variable of interest, and they update the variable of interest with the value computed in the step 1. Just as you probably won't win 20 questions with the first question, you probably won't optimize your model with a single call minimize. Most applications perform optimization in the loop. So we are gonna use the loop in here, and the following code given an idea what can optimization look like. You can see this code, but you can see this code too because we are gonna take a loop in here. So for I in range of 100, and in this loop first we have to run this minimize. So in the minimize we pass the loss, so we have to put the placeholder value which is the x and y. So I'm gonna name x equal to, I'm gonna use the x equal to 1 2 3 4 5, and remember this is the small x and this is the capital X, and y equal to 2 4 5 4 5. So you got x and y value. Now in here just I'm gonna run this minimize in this sesh.run, and then I'm gonna feed the dictionary which is x placeholder and y placeholder. Okay, now let's try to run. Oops. Okay, it runs successfully. Now that we run the minimize, so it is automatically gonna minimize the loss, and then we are gonna run the W and B. Now in here you can see we got the random value, but whenever we print the value in here, let's try print w.eval function. You can use run function too. Let's try to use the run function so you can't confuse. Slash.run. I'm gonna call the W, and we have to pass the feed dict, which is x and y placeholder, and then I'm gonna copy this and paste this in here and change the variable name to B. Okay, now let's run. You can see we got a lots of value in here, like 100 times, 99 times we got values. You can see every time whenever the W and B is trained, you can see we got the different value in here, 0.12, 0.39 and so on. But at the end you can see we got the last value is 1.0 of W and 0.4 of B. Okay, so that's how you can train the model using the changing the value of W and B using the optimizer. So I just pushed all of this in one line. So you can see we got first minus value, negative and so on, so we got the positive value. Now let's run this at 1000 times. So at the end you can see this is kind of stopped at W at 2.11 and B at 2.11 and W at 0.62. So that's our actual value of W and B. So let's use the last value because this is the actual real value of W and B, because before all of this value the model is training or model is not complete of training, but at the end you can see we got the trained model at W equal to 0.62 and B equal to 2.11. Now let's try this. I'm gonna cut this and print this in out of the loop. So you can see you got W equal to 0.62 and B equal to 2.11 at the 999th range and so on. So we got loss equal to 0.48. So that's how you can train the W and B and change the W and B variable using the optimizer, and that's how you can find the real weight and real bias using the training of the models again and again in the loop. And you can even change the 0.01 of learning rate into, let's try 0.1. So you can see whenever I run this we got the whole different value. You can see we got the none. So that's the important one. You can choose the real learning rate so you can see the actual output. So that is it for today's guys. In the next video we are going to talk about how actual gradient descent algorithm work. In the today's section we just saw how gradient descent optimizer work, but in the next video we are going to talk about how actual algorithm work of gradient descent, and you can see all of this function of mathematics, and then we are going to see the AdagradOptimizer. So that is it for today's guys. See you guys in the next video. Till then, like my video, share this video to other programmers, subscribe to my YouTube channel, hit on the like button, hit on the bell icon so you'll never miss my latest update. See you guys in the next video. Thank you for today.